All right, so now we're gonna start talking about air current. Oops. Start talking about air currents. So air has four properties that determine how it circulates in the atmosphere, which those are being like density, water vapor capacity, adiabatic heating and cooling, and latent heat release. So starting off, we're going to talk about air density and how it affects air circulation. Air density is the mass of all molecules in air in a given volume. The density of air depends on its movements, meaning that less dense air rises while denser air sinks. Because of density differences, warm air rises whether you are in your room or in the atmosphere. Secondly, water vapor capacity also determines air circulation. Warm air is not any less dense than cold air. It just has a higher capacity for holding water vapor. This means that places with a lot of precipitation and hot days have high humidity, meaning that their warm air contains a lot more water vapor because it has a higher capacity for it. Thirdly, change in pressure affects the circulation of air. As air rises higher, the pressure decreases. As air molecules are heated, they move faster, they spread out and become less dense. Lower pressure allows rising air to expand in volume, which inevitably leads to a decrease in air temperatures. The concept of change in pressure is best explained through the processes of adiabatic cooling and heating. Adiabatic cooling is the cooling effect of reduced pressure on air as it rises higher in the atmosphere and expands. Adiabatic heating is like the opposite. It's the heating effect of increased pressure on air as it sinks towards the surface of Earth and decreases in volume. Lastly, air circulation is defined by latent heat release. Latent heat release is the release of energy when water vapor is in the atmosphere and when that water vapor condenses into a liquid. This releases heat, hence the name. Moving on to convection currents, this kind of takes into account all the air currents and kind of summarizes it and explains it in scenarios. So major contributors to different climates of the world in the atmosphere is the convection currents, which are global patterns of air movement that are initiated by unequal heating of the Earth. When the humid air at Earth's surface increases in temperature, the dense air decreases. As a result, air begins to rise and begins to experience lower atmospheric pressures and adiabatic cooling. The cooling causes the air to reach its saturation point, which leads to condensation and precipitation that will be happening around this area. The condensation causes, like I previously mentioned, latent heat release, which offsets the adiabatic cooling. The heat beats off the cool air and makes the air expand further and rise even higher, which is around this area. When the air finally reaches the top of the troposphere, it begins to chill through adiabatic cooling, which we again explained previously. At this point, the air contains little water vapor, and as the warm air rises, the cold and dry air at the top is pushed horizontally. So it can go left or right. This reduces the volume of which it can hold moisture, which is caused by the adiabatic heating, as we said before. When the air reaches the surface, it is hot and dry and circulates back to the starting point. Once again, picks up moisture, so it's humid, and starts the cycle once again. One example of a convection current in action, which is pretty cool, is hurricanes. Hurricanes begin as clusters of clouds and thunderstorms or like tropical disturbances. Low pressure areas feature weak pressure gradients or with little to no rotation, which is a reason why a majority of these disturbances die out. But some don't die out and they become hurricanes. And through the release of latent heat, the areas within the disturbance are warmed, which causes the air density inside to lower, dropping the surface pressure. The wind speeds up. It's the wind the wind speeds up, which begins to increase the cooler air rushes underneath, rising warm air, and the wind begins to rotate when it is subject to the Coriolis effect. The incoming winds begin or bring in even more moisture, which begins to condense into more clouds, which in turn will release more latent heat. And the hurricane's low pressure center is the eye. And so that's like the center. And then the area around the eye is the eye wall. But you can also think of that as the convection current of the hurricane because it's rotating, causing like these really massive winds. Some examples of the convection currents are the Hadley and polar cells, but we'll go over that in the next video.